now that we've introduced a radical function, we're going to see what happens when we change the a value. So what happens when I start with y equals the square root of x, and I put an a value in front right here. So I'm going to look at exercise 1 and exercise 2, both of which handle that exact question. So for exercise 1, we're going to say what happens if we have 3 square root of x. In other words, if a equals 3. Well, if that is the case, in other words, in this situation, a is greater than 1, I'm going to draw my table. And I'm also going to draw a graph over here as I find my values. And if you'll remember, a square root function, you cannot put a negative number in for x. Because if I put in a negative number in for x, it's undefined, right? I can't. I can't get a solution. So that means I'm only really talking about positive x values. So let me start. And let me first of all actually put in I just realized I had to go out a little further than I was planning. Okay, and I'm going up to, let's see, so let me go back and do my parent function, 0, 0, 1, 1, 4, 2. Because we're going to compare our new function to our parent function, y equals square root of x. All right, now we'll put in the numbers for our new function. Let me just black that out so we don't think it's part of the whole package. 0, 0, 1, 3, 4, if square root of 4 is 2, now we can only use the positive values for x, right? And because we're only using the positive values for x, the answer here is going to be square root of 4 is 2 times 3 is 6. And then I'm going to put in 9 because it's my next even square root. The square root of 9 is 3. 3 times 3 is 9. And I kept thinking I'd have space, but I'm just going to leave those blank. All right, let me graph that in red, and we can compare y equals 3 square root of x to y equals the square root of x. So 0, 0, 1, 3, 4, 6, 9, 9. You can see pretty healthy stretch. Y equals 3 square root of x. So this is a vertical stretch by a factor of 3 relative to the parent function. So that's if a is bigger, and I am sure, because you are experienced with these, you'll know exactly what's going to happen if a is smaller. So if a is less than 1, but greater than 0, in other words, if it's a fraction, but not only do we want it to be a fraction, we're also going to make it a reflection, or we're going to make it a negative number and see if we can get a reflection. So I'm going to call that the absolute value. In other words, what if we have a fraction that could be negative? And for my equation, I'm going to try out y equals negative 1/2 square root of x. So we've both taken a fraction for a and we've made it negative to see what happens. Let me draw my table. Okay. And I'm also going to draw my graph over here on the right. And this one is going to have to go a little bit further Here's my y-axis, my x-axis, and I'm going to take this all the way out to 20. 1, 2, 3, 4. Okay, and here, these are going to look real. This is going to look interesting because I have to go out to 20, and here I'm only going out to -1, -2, +1, +2, +3, +4, +5. As you'll see, we're not going to need to go further than that. Okay, so again, let me put in my parent function in black. 0, 0, 1, 1, 4, 2. That's my y equals square root of x function. Okay, now I'm going to look at y equals -1/2 square root of x. And if we go through our values, if x is 0, y is 0. That does not change. X is 1, y is -1/2. I'm going to jump to 4 because it's just easier that way. Square root of 4 is 2. 2 times -1/2 makes -1. And if I jump to 9, square root of 9 is 3 times -1/2 is -3/2. And last, I'm going to try 16. Square root of 16 is 4 times -1/2 is -2. My dogs are barking up a storm. Hang in with me. Hopefully they'll stop soon. They've probably seen a dog outside. All right, 0, 0, 1, -1/2, 4, -1, 9, -1/2, right, squeezing in here, and 9, let's see, and then 16, I get all the way out to -2. You can see this is an incredible shrink. It does not go far at all to have it. It's literally half, and it's also a reflection. All right, I'm gonna stop this before my dog gets carried away again, and we're gonna move on to what happens if we now add a number here, and then later if we add a number inside the radical.